All right, let's take a look at our lesson for today. We're actually working with area and volume again, but we're going to work with them with regards to like how an AP question might be, presented to you. How might you see this? And we're going to go through also some calculator input so that we are comfortable with, or at least are familiar with, how to put these in our calculator. Okay, so let's take a look at what we have. So we have two functions defined, f and g. Okay, great. So we're looking at, so we have this function f and this function g. Okay. And we are told R and S are the two regions enclosed by the graphs of f and g shown in the figure. Okay, now in the figure, they don't really tell us which one is F and which one is G, so we're going to have to figure that out for ourselves when we get to our calculator. Find the sum of the areas of the regions R and S. Okay, so this goes back to our work with area between curves. Do we remember? Of course, it's all formula-based, right? Area between curves. Do we remember that formula? Remember the integral from the intersection of the two curves to, big minus little? Okay, great. So let's navigate over to our calculator. In just one second, let's plan our work first. So what we're going to have to do is, it looks like this function, whichever one it is, I'll just draw it in pink. It changes places, right? In the R region, it's the big, and in the S region, it's the little. So we're going to have to actually find this intersecting point so that we'll be able to set, we're going to actually have two integrals because the big changes places, right? And they want us to add those areas together. Okay, so let's think about our work. So we need to graph them. We need to figure out which one is the pink one, is that F or G? And we need to find the intersection of the two, okay? All right, so let's navigate to our calculator. And I'm going to do an alpha order. F, I'm going to put in F1, and then G, I'm going to put in F2. And I'll make a little note on my paper, which I do, so that I don't get confused. So F1 is 1 plus x plus, and then e to the x squared minus 2x. Okay, so there is my first function. That's the function called f. So I'll go ahead and log that in there. My second function, to get to that, we would hit tab, and that takes us up to this menu again and allows us to put another function in. So here we're going to write, that's what, x to the fourth. So x raised to the fourth. Then it is minus 6.5 x squared. And then plus 6x plus 2. And of course I need to double check to make sure I input it right. That would be terrible to do the whole problem with the input wrong. Okay, looks good. And then we hit enter. Okay, so we have, looks like on our document, they just have this little area right in here, right? So this little area. So the top function, which I actually, strangely enough, colored pink, right? That's the red one. The red one is the pink one, and that is G. G was F2. So G is right here and then underneath. And we also mentioned we're going to need to find this intersection point, the intersection point. So we're going to hit Menu, Analyze Graph. We're going to do our intersection, number 4. And this is the intersection we want. We go to the left of the intersection and click enter, the right of the intersection, and here's my intersection. Now, I know that I'm going to need this number to put in my integral. So what I'm going to do is I'm going to click on it and highlight it, and I'm going to store it. That's going to save me time. So this little blue STO right above the VAR, that's our store button. So I hit Control VAR, and then I'm going to call it, I'm boring, I'm just going to call it A. That's A, and then hit Enter. Now when I hover over it, I can see that this number is linked to A. So if I type in an A, it's going to pull up this number. Okay, I'm going to pause here for a second. Are we okay with the calculator input? Okay, so let's go and let's set up our integrals. Let's go back to our document. Okay, so here we go. I'm going to, on the picture here, and this is perfectly fine, I'm going to document that I put this in as A. I'm going to tell what the value is so that I don't have to write this value over and over and over again. It just would be helpful to just write an A. So A is 1.0328, and it keeps going. I'm going to use the whole number. So now let's write this here. I put this in as F1, and I put this in as F2. And this one just, was blue on my calculator just to help me. You don't have to write this. I'm just making sure that I get it paired up correctly. It would be terrible to write this whole thing up and then it, be wrong. Okay, so here we go. So the integral of region R is 0 to A, and A is that number that we found. And I don't have to write it out. If you want to, if that really bothers you, you can go ahead and write the number out. That's fine. And it's going to be the pink one, which we said was F2, which is G. And I would encourage you to just use the name of it. Don't write it all out. Because if you write it all out and make a mistake, you're going to lose points. Like if you write down a plus 6.5 instead of minus, though, there you go, there it's gone. So just write just G. You can write G of X if you want, or just G minus F dx. Okay, so that's to find, just I'm going to make a note to myself, this is to find the area for R. Okay, plus my next integral is going from A, that number that we found, the intersection, all the way to the x value of this coordinate point, because we're with respect to x. So to 2, and this time we are reversed, right? It's not the G that's the big, it's the F that's the big. So this would be F minus G dx. Okay, and this actually calculated for us the area of region S. You don't have to write that on your paper. I just want to make note for us. Now I'm going to go back to my calculator and I'm going to input that all into my calculator all at once and get the answer. Okay, so here we go. So we need another page. We need a calculator page. So I'm going to hit Control Doc to give me another page. And this is a calculator page. Okay. So I always get the integral from this menu, and I know there are other ways to do it. I want to do the integral, so I just pull that down like that. My first one is 0 to A. I just type in A of. Now, we don't really want to spend time typing in those equations again. That it's possible for us to, make an error. So instead, if you click the VAR button, it lists everything that we've done. I can just use it. And we said that I put G in F of 2. So it's going to be, or F2, it's going to be F2 of X minus, and again, I'm going to go to where my variables are stored, VAR, F1, which is where F is housed, of X, and that's dx. And I'm going to go ahead and add to that. I'm just doing it all, let's not get crazy on us here. Plus, and I'm going to put the other integral up here too. I'm not going to do them separately, just do them all at the same time. You can do what you want. You don't have to do that. So calculus, we're doing the integral. This time we're going from A, we're going to 2. And this one we did, if you recall, it was the f function first, which I have stored in f1. So f1 of x minus, and then our g function, which is stored in f2 x. Now I encourage you when you enter this to hit Control Enter. Hit Control Enter every time you're trying to get a number, because it does crazy stuff if you don't do that. It gives you exact things. We don't want that. So this is my answer. Okay, and I can double check if I wanted to make sure I input it correctly, which we did. So this is the sum of the areas of regions R and S 2.004. We're always going to the thousandth unless told otherwise. The thousandth. Okay. So here we go. Our answer is going to be 2.004. All right, how are we doing with the sum of the regions? Everybody okay? Okay. Let's look at part B. It's talking about region S. Okay, region S is the base of a solid whose cross section's perpendicular to the x-axis. Okay, let's pause. Perpendicular to the x-axis. We remember, hopefully remember, that means we need to use x's. Okay, and the cross section is a square. Find the volume. So let's recall about our work with cross sections. What we do is we integrate, to get the volume of a cross section, we integrate the area formula. I mean, that's what we're going to do with respect to x. That's what we do with cross sections. So how do we find the area of a square? The formula for the area of a square is side squared, right? Side times side, because it's a square. Now we're in region S, so let's go over to this picture for a moment. We are perpendicular to the x-axis. So what I'm looking at, this would be the side. This is one side of the square. That's one side. So I think it's obvious to us, that's just a representative side. I just randomly picked a spot. You could pick any spot on there. You can see that they're all going to be different lengths. The sides are going to be different lengths. So we can't just represent the side with a number. We have to represent the side with an equation or a variable. So we use, you know, big minus little. Gotta love big minus little. So big is this, you know, equation right here. Big, which was, what one was that? That was F, right? And this one was G. Big minus little, so F minus G. So our side, let's just fill this out. The side is F minus G, and put in the area formula, that's F minus G squared. Okay, so here we go. So the volume is going to equal the integral of, the beginning is our little A point, which we've already, we already put that right here, so we don't have to redefine it. It's defined right here by the picture, the graph. So we're going A to 2 of F minus G all squared. Okay. So let's go back to our calculator. Great. So we're going to get our calculus, menu, calculus, integral. We're going to go from A to 2 of parentheses. This is going to be F minus G. So it's the first function, which is F1, minus the second function, which for the way we input it is F2. And I need to square that whole business right there. I need to square the F1 minus F2 squared, and then go over here, dx. Control Enter, and we have our cross-section volume, which is 1.283. 1.283. So let's go back. Okay, so this volume is 1.283. Okay, how are we doing with cross sections and using our calculator? Everybody okay? Okay. Not for squares. Not for squares. We're literally, whatever the cross section is, we're just integrating the area of it, whatever it happens to be. Now with discs and washers, the cross section happens to be a circle. So that's where the pi comes in, pi r squared. But for the other figures, you know, like squares and triangles, and it's just their regular area formula. Okay. All right. This is a continuation. This problem, we have one more part of this problem, but it's the same prompt. So we still have the same calculator input that we were. That hasn't changed. Let's see what this wants us to do. Let h be the vertical distance between the graphs of f and g. Okay, let's remind ourselves which was which. And if we don't remember, we can go look at the calculator. Okay, let's see. Let's look at our graph. So let's see. F is that 1 plus x business, and that we have in F1. Okay, so that's in F1, so that's the blue one, right? And G is the one that is in F2. G is the x to the fourth one. So let's go back, and they want h to be the vertical distance between the graphs of f and g. Okay. So h is the distance between f and g. Okay, so this is g. Okay, and this one was f. And I know you're not going to be surprised, probably not surprised, but it's big minus little, right? This is h, this is distance between f and g. So h is big minus little, so f minus g. Okay, so h is the vertical distance between the graphs of f and g. Got it. In region S. Okay. Find the rate at which h changes with respect to x. So I'm going to pause here. So dh dx equals question mark when x equals 1.8. So we want to find the rate at which h changes. So apparently we need to take the derivative of this, right? The derivative of h. We want dh dx. Luckily our equations are all with respect to x anyway, so this is like, you know, fine. It's fine. So we're actually going to do that in our calculator. Okay. So we're going to do, we need h prime of x at x equals 1.8. That's what we need. H prime of x. Let's see, how can we do that? Okay, there's several ways we could do this. We need to figure out how to make a new equation, there's several ways. I really like the grapher. That's what I'm going to do. So I'll just take you there to the grapher, and I'll walk you through. You don't have to do it this way. But I'm going to go up to the tab, and I'm actually going to, just to help me so I don't have to look at all those graphs, I'm gonna uncheck those two graphs so I don't have to look at them. And I want to make my third function, I want to make it f minus g. I want to make that f minus g, which is f of x minus g of x. Okay, that's what I want to do. Okay, like I said, there's other ways to do this. Okay, so now I have f3 is actually h. Okay, and I'm going to hit enter so it's logged in there. So that's actually h. So I'm going to go over to my document. I'm just going to make note of that. So I am putting FH is in F3 of X. That's where I put it. That's where H is. Okay. So I'm going to go to my calculator screen, and I want to do a derivative. So we go menu, calculus. Okay, come back. No, oh, it knows I love integration. Look how it just popped up there. I didn't even ask for it. Oh, okay, it's all right, little calculator. You know what I love, but we need to actually look. Oh my gosh. Okay, let's try this again. So menu, calculus. There we go. We want derivative at a point. That's what we want, derivative at a point. The variable is x. We want it to be at 1.8. We want the first derivative. Okay, great. I want my h function in here, and I pull here's where all my stuff is stored, var. That is my h function. Okay, that's what I want. I want the derivative of the h function at 1.8. Control Enter, and I have my derivative. Notice how I didn't do anything by hand. I don't want you to do stuff by hand when you have a calculator. Okay, so we go back. Is everybody okay with that? Okay, so we go back to our document. And this is all we need to write, showing that we need to identify what h is. We listed it. And we need to say we're taking the derivative of it. We don't have to physically take the derivative of it. But we're saying this is what we're doing in our calculator. We have that defined. We're taking the derivative of this. And so that value is negative 3.812, and we're done.